Hello and welcome to this video on implementation of matrices and vectors in Matlab. Since Matlab is based on matrix calculations, it's very important that you're familiar with this topic. So what's the content? Here it is. I start with the implementation by hand, then we will talk about the column notation, which is a nice add-on to implement matrices and vectors. And finally, I will tell you something on functions for matrix implementation. If you like this video, please give me a thumbs up. Okay, we start with matrices. Here is an example, two matrices, A and B. A is a 2 by 3 matrix, that means 2 rows, 3 columns. B is 4 by 2, 4 rows and 2 columns. How do we implement A and B? In Matlab, you use square brackets, and inside of these square brackets, you put the entries row-wise. That is, we start with the first row of A, it's 1, minus 1, 2. And then the semicolon separates the rows. That is, after the semicolon, we have the second row, it's minus 2, 3, and 5. And similar for B, we start with the first row, 1 and 2. Then the semicolon separates the second row, it's 3, 4, and so on. So what about the implementation of vectors? Actually, this is very easy because vectors are just special matrices with only one row or one column. If you have one row, it's a row vector. If you have only one column, it's called a column vector. Here are the two possibilities. X is 1, 2, 3 are the entries separated by semicolon. That means X is a column vector. You just have one column. And Y is 1, 2, 3 without semicolons. That is, all the numbers 1, 2, 3 are in one line. So Y is a row vector. Okay, I switched to Matlab and now I want to implement some matrices and vectors. So we start with A. Square brackets 1, 2, 3 is the first row, 4, 5, 6 maybe the second, and 7, 8, 9 is the last row. And this gives a square matrix with 3 rows and 3 columns. Now let's implement a vector. The vector 1, 2, 3 separated by semicolons, so we get a column vector. And if I implement the vector y without semicolons, I get a row vector. If you want to switch from column to row vector, you can use the transposed command. So x with a comma gives you x now as a row vector. And if you use y with a comma, then you get a column vector. Here is the next example. I want a vector which contains the numbers from 1 to 10. I already implemented it here. And here is a row vector. And now you can imagine if you want the numbers from 1 up to 100, then it's hard to type in everything by hand. Here you can use the so-called column notation. So I write x equals, the starting value is 1. The step length is also 1. That is, you increase always the numbers by 1. And you end with 100. And here you see, per default, with this column notation, you get a row vector. If you want a column vector, you have to transpose it. So you write x equals x transposed, and then you have a column vector. Okay, you also can increase by different values. For example, we start from 0. We have the step length 0.1 and we go up to 1. And then you see it's always increased by 0.1. You also can do something like that. You start with 100, you decrease by -1, and you end with 1, and then you get the vector vice versa, which starts at 100 and ends with 1. If you want to implement special matrices in Matlab, then maybe Matlab provides a function for this purpose. Here are some examples. Let's go from top to bottom. So the I matrix is a unit matrix. That means we have ones on the diagonal and zeros on the off diagonal. The 3 in the round brackets tells you that the size is 3 by 3. Unit matrices are always square matrices. The next one is zeros. Here we have two possibilities. Zeros 2 gives you a matrix which has just 0 entries, size is 2 by 2. And if you have zeros 3, 4, then you get a 3 by 4 matrix with 0 entries, that is 3 rows and 4 columns. Similar is the command ones. You get a matrix where all entries are 1. Ones 2 is a 2 by 2 matrix. Ones 3, 4 gives you a 3 by 4 matrix. And if you multiply the matrix ones by a 3, then you get a matrix which has entries 3. The last is the random matrix. So this matrix contains random numbers. The size is 2, 3, so 2 rows, 3 columns. And the random numbers are from 0 to 1.